Really too bad at all. We're going to still be writing up terms of sequence. We're going to practice the listening. We're going to be practicing the recursively defined again, because that can be a little dicey. But the only really new thing I have for you today is we're going to add the terms together. So that's why I said have your calculators out. If there's only 5 terms, it's not a big deal to add 5 numbers together. If there's a lot of them, there is a function in your calculator that can do it for you. I'm not going to add 20 terms up together. Let's get serious. There is a function on the calculator that would do it for us. So first up, and especially good review for anybody that was gone on Friday, and several of you are gone Friday. Write out the first 5 terms of the recursively defined sequence. That just means the next term is dependent on the previous term. You can see they started you with 7. Now, we have to know our subscripts. You're going to have to know this again for today for something else. What is higher, k plus 1 or k? K plus 1. So this is just saying to get your next term, it's the last one plus 4. So what is my next term if you're starting with 7? 11. 7 plus 4, 11. What's your third term if you're using 11? 15. 11 plus 4. Easy to see the pattern. Next term. And your fifth term. So we're going to be doing some more of this today where you do have to write out the terms, but then we're also going to have to find the sum of them. Not that that's that hard, but that's just what we have on tap for today. Now, some of the terms, some of the formulas today are going to start, I don't know if you've seen this or not before, have this little exclamation point it looks like. In the world of math, that means factorial. Have you heard of that before? Yeah. Okay, it is in our calculators too. I'm going to show you that and we'll talk about it. So just to make it easy on you, like if I want 4 factorial, you start with 4 and you go all the way down to 1. And you're going to multiply those. So what's 4 times 3 times 2 times 1? Got it. 3 factorial. So you would start at 3. 3 times 2 times 1. 6. Now if you had something bigger, like I don't know, 12 factorial, I can't say by hand I'd want to multiply 12 times 11 times 10, clear down to 1. And I am going to fill this in too. But let's take a look at your calculators here. So in your calculator, just if you forgot where it is, it's in your math menu and it's under probability. It's number 4. So I'm going to punch in 0 factorial just to show you that's kind of a unique little answer. A lot of kids think you get 0, but let's check it. So math menu, probability, and then I put the exclamation, the factorial on it. So 0 factorial is that little unique case. 0 factorial is 1. And again, if you're like, oh, I'm not sure, is it 0 or 1? Punch it in your calculator and see. Now, one thing to warn you about on your calculators. Most of the time, you have to kind of keep the numbers a little low. Like if I gave you, I don't know, 99 factorial, is that going to be a big answer? Yeah. 99 times 98 times 97, so on and so forth. If you try to punch that in, try to punch it in. Punch in 99 factorial. You get a little error message, okay? It's so large that it doesn't fit on the display of your graphing calculators. So just be aware of that, okay? All right, write out the first 5 terms. Notice I got fancy here, starting with 0. Okay, so we're going to do 2 to the 0 over 0 factorial. Now again, you're probably going to have less work than I do. I always like to write out all the steps. 2 to the 0 power, anything to the 0 power. And 0 factorial is that special case of 1. All right, let's keep on going. So now I'm going to do 2 to the first over 1 factorial. Well, what's 2 to the first? 1 factorial. So we got 2 for that guy. All right, 2, I'm on 2. So 2 to the second over 2 factorial. Well, what's 2 squared? 2 factorial, 2 times 1. That's easy enough. All right, 5 terms, we gotta keep going. We're getting there. So 2 cubed over 3 factorial. I already heard somebody say 8 for 2 cubed. What's 3 factorial? 3 times 2 times 1, 6. Well, it doesn't give us a whole number, but we could at least reduce it. All right, and then of course we want a total of 5 terms. You can see I've got 4 up here. Let's get this. All right, so we're going to have 2 to the 4th, 4 factorial. What's 2 to the 4th? 16. 4 factorial, 4 times 3 times 2 times 1. And let's reduce it. Got it. So this is why I said too, you might your calculators today, because like I said, we're working our way up to doing the sum of these terms. You would have to add those up with the fractions I know how some of you love fractions. Little judgment, no judgment. Okay, evaluate these. Now, let's talk about them. Could you straight type A and B in your calculator? Let's be honest, sure you could. Can you type C and D in though? No, with the variables. So that's, I'm gonna use the same method I'm gonna use on C and D for these with the numbers. Plus, you never know, what if I'm a real jerk and I give you like 85 factorial, which you couldn't just straight type in your calculator. So, first things first, you're going to start with the larger expression, which in this case is 7. So I'm gonna leave the top. So I'm going to expand or write out 7 factorial. So I'm thinking in my head, thank you, 7 times 6 times 1. But wait a minute. Instead of me keep writing the 4, 3, 2, 1, I'm going to go ahead for those and put the factorial on here. I'm going to write over that dot. So that has my 4, 3, 2, 1 in it. Why did I stop there? Because it's on the top. 5 factorials on the top, we can cancel them. So what is your final answer without a calculator? 1 over 42. And like I said, you could type that one straight in your calculator, but I can't for C and D, so I'm using the same method. Same spiel, I'm going to start with the larger expression. I'm just going to fill in the bottom for right now. So basically, we're trying to use the larger one to reduce it down to something in the bottom or the top, wherever we're at to cancel. So I mean, okay, 8 factorial, 8, 7, 6. I think I'm going to stop. I'm going to put the factorial on for 5, 4, 3, 2, 1, because I see a 6 factorial down here. Without a calculator, final answer. Final answer, which is? Don't all yell at once. Thank you. Wait. All right, I'm going to do the same idea on the next two, which I cannot punch into the calculator. I started coughing again Friday, and I'm not very happy about it. Okay, which is bigger, n or n minus 1? So we're starting here. So if I wrote out the top, n factorial, n minus 1, n minus 2, n minus 3, n minus 4. Clearly I'm not going to do all of that. I'm going to stop at the n minus 1 because I see the factorial on the bottom. So then I can just cross them off, and we're left with that. Same idea on this guy. Start with the bigger expression, which is larger, n plus 2 or n. So we're going to start on the top. So of course we're going to have n plus 2. What would be your next term? N plus 1. Yep. Next term. Now, just for fun, humor me, what would be the next one? N minus 1, n minus 2, n minus 3. We could do it all day, but I'm going to throw the factorial on for all of those because I see it in the bottom. Now, up to you. I don't care. If you want to leave your final answer, n plus 2, n plus 1. I have some kids that like to FOIL it out. I don't know if you want to FOIL it out. N squared plus 3n plus 2. I'll take either version. It does not matter to me. So those to me are like the one tricky things of the day. You can't use your calculator to help you. You have to know to start with the larger expression. Any questions on this? Don't get the cough, Jackie. Hit it, Kaden. Each term lower. You started at the top, just like 4 factorial, 4, 3, 2, 1. You're going down by 1 each time. We're all getting sick. Okay, so like I said, we're kind of leading you up to, we want to do the sum of the terms. Not that that's hard at all, but you have to know the notation. So you're going to see this sigma. Looks like a big capital E, sigma, Greek letter sigma. When I see that, that's just my signal that, hey, you got to add up the terms, okay? So the bottom number is going to tell you where to start. Like remember on some of the previous problems, I said start at 0, start at 1. It's going to tell you where to start. The top number, the upper limit it's called, tells you where to stop. And then of course you're going to add them together. So you just have to recognize when I see that sigma notation, I'm also not just finding the terms that it asked me for, but I'm going to add them together. So here we go. I'm going to start finding the terms first. So I'm going to start with 1. So I'm going to do 3 times 1, 3 times 2, 3 times 3. I'm going to stop at 5. So I'm going to calculate these out, of course, here in a second, but I started at 1, the lower limit, ended with 5. Now let's just calculate those quick. What's your first term? 3, second term, 6, third term, 4th, and then of course 3 times 5. And notice I put the pluses in between them, okay? The sigma is telling you to add those terms now together. So I see some of you already punching it in. All I did was straight type that on my calculator just as it appears. Add them up. What do you got? For a total of 45. So that is the new exciting part of the lesson we're going to do today is add the terms together. Now again, you might have less work than I do. You might have just gone straight to the 3, 6, 9, 12, etc. I'm just jotting it down on the side so you know how I'm getting it. Now, same thing. Oh, I like this one because we're going to start with what number? And I got to end at, that's not that much, okay? So first I'm going to do 1 plus 3 squared, 1 plus 4 squared, 1 plus 5 squared, and then I'm going to stop at 6. So again, some of you might skip writing that and can mental math them. So my first term is what? 10. And I know I'm adding because of the sigma. Second term, 17. Third term, and your fourth term. So just add those together for me. What's 10 plus 17 plus 26 plus 37? 90. Now, if you had a lot of terms, let's say 20 terms, is that obnoxious to add up 20 numbers in your calculator to stand there and add? It is. So we are going to show you how you can do it on your calculator if you have to do a lot of terms. Just wait for it. Okay, this one. So we're going to start with 1. We're going to end with what? What's your first term? It's not, there's no typo on it. I haven't lost it yet. First term is 4. That's all I got. What's the second term? And the room goes silent. Is there any variable on the 4? So every single term is what? So this is what we call a constant sequence, just for fancy vocab there, where all the terms are the same. Now I need the sum of those, or I mean, let's just mental math it. You can just do 4 times what? Yeah. So that is an example of a constant sequence. There's no variable on the 4, so every single term is 4, just plain 4. You don't even have to do anything. Now, the next one. If you take a look at the next one, here we're going to use our calculators, my friends. I got some calculator screenshots up here for you. Now, I don't know about you. I don't want to put 1 in, 2 in, 3 in, 4 in, all the way to 10, and then add all those fractions. That sounds pretty gross, okay? So your calculator will do it for you. You can get a fraction answer too. I'm going to show you, how to type these in. If you get into your math menu, and it's number 0, I just hit 0 because I'm too lazy to scroll. It pulls up the sigma for you. Now, notice I got fancy over there. I used J for the variable. You can use whatever variable you want. I'm going to make it easy, and I'm just going to use X off the X, T, theta, N key. So I'm going to type in X. Notice it already jumped over to me. We're starting at 1. I'm going to right arrow, 10, right arrow. And then I'm going to pull up the horizontal fraction bar. You don't have to, but I'm going to go ahead and do that. So I'm going to do my... Now, yours might be a little easier to pull up than mine on this Model 6. I hate typing on this thing. And then 3x I'm going to use, plus 1. So this is going to take each 10 terms, the first term, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, and add them all together for you for a grand total answer. There you go. And round to whatever. I don't care. If it doesn't specify like what to round to or a fraction or a decimal style answer, I don't care. You can put whatever. But any questions on finding that math 0 function? Because I do not want to add those 10 terms. No way, Jose. Okay, use sigma to write the notation and then find the sum. Okay, all right. So they want you, oh boy, that's kind of messy, to write the sigma. Okay, all right. Well, let's first come up with the formula. The sigma's only there because of the adding. We need the formula. What is the pattern between those numbers? I need the pattern of the numbers first. So I'm hearing multiples of 3, I'm hearing powers of 3. Those are different things. Which is it? house, 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. So I'm going to do, pick a variable. What do you want for a variable? A. So I'm going to do 3 to the A.
I said K.
Doesn't matter. Okay, 3 to the first, of course, 3. The question is, what's your upper limit? This is 3 to the 6th. Now, 2 ways you could do this, and I don't care. It asks you to find the sum. I don't know if it's worth hitting math 0 and typing that in, or can't you just straight add those numbers? Like, I don't know which is quicker. So you decide, is it quicker to do math 0 and type this in, or to straight add the given numbers? I need a total sum.
1,092.
Perfect. And I don't know how you got the 1,092 if you did math 0, typed them in, that's your call, okay? All right, we're gonna do the same thing. First, I'm gonna come up with the formula. Now, clearly we're adding the terms together, so that's the sigma. Let's get the formula. Well, I see they all start with 1 minus. We've got these fractions squared. Well, all the denominators of the fraction are staying as 6. It's the numerators that are changing, okay? So that's going to be my variable. I'm just going to do n for numerator, I don't know. Now, it's up to you. You can put the brackets around if you want because it looks like it, sure. Draw my sigma. Now, what is your first value for n? The first numerator is what? 1. The last numerator is 6. That's a 6. Now, this is one I can't say as I'd want to type in all of that stuff on my calculator and add them. I would probably go math 0. So let's punch it in math 0. I think that's going to be a little easier. So math 0. Okay, again, I'm just going to use X to make it easy on my calculator. Let's be careful how we type this. I hate typing. Okay. Now, you got to be a little careful typing this one in. This is why I'm doing this one with you. Because when you hit math 0, it already defaults to the parentheses. So think about those as like the brackets on the outside. Meaning, I'm going to do 1 minus. Now, I'm going to put parentheses around the fraction, the n, or in this case, x over 6 squared. So I'm going to do parentheses. I'm going to pull up my horizontal fraction bar. Maybe, I hate this thing. Oh, this is not,
You can just click alpha and then where X is.
Mine doesn't do it.
Oh, it doesn't.
It doesn't. That's why I'm up here yelling at this thing. Sorry, kids, sorry. Like, it doesn't read. I am hitting it. Move over. Okay, back to it. Let me get my horizontal fraction bar here. That shouldn't have been so hard. X and then 6. And then I'm going to go outside of this and put the squared on. Whew, this shouldn't have been so hard. So mine kicked out a fraction. You might have a decimal depending on how you typed it in. The decimal's about 3.47 if you went that route. I'm just going to write down the 125 over 36 for you. Okay. Any questions on typing that one in? That was painful. Okay, now, last thing I have for you today. And this is more of the same. It's the notation. So, focus, my friends. Definition of a series. If it asks you to find the series is just a little fancy vocabulary word to do the sum. You are still adding the terms together. Now, we have actually been doing the first thing. We have been finding technically the finite sum, the sum of the first 10 terms, the sum of the first 5 terms, or what they call the partial sum. I'm going to show you, we're going to start seeing this more. You might have the infinite sum. We want to know what's the total of all the terms out to infinity, where you might be like, how the heck am I going to do that? I'm going to show you. How am I going to do that all the way out to infinity? We're going to use patterns. We're going to look at the first few terms and try to find a pattern. But we've already been doing the first one, the partial sum that also can be called the series, etc. So here we go. We're going to do some more series or sums. You might see it written this way. It's all the same thing. It's just the notation. If it asks you for S2, I need the sum of the first 2 terms. So instead of having the sigma with the 1 and the 2, it's going to say find S2, or the second partial sum. Third partial sum of the first 3 terms. Fourth partial sum of the first 4 terms, so on and so forth. So find the first 4 partial sums. I need 4 answers out of you. I need the sum of the first term, second terms, third and fourth. Well, let's start with the sum of the first term. Let's make the first term. Put a 1 in here. What's 2 to the first? 2. So you have 1/2. That's the only term. There's nothing to add with it. That is just the first term. Now, when I do the sum of the first 2 terms, I already figured out the first term. I just kind of stole it from up there. What's your second term? 1/4. Okay, without a calculator, we can add that. What's 1/2 plus 1/4? 3/4. Okay, sum of the first 3 terms. Well, we already got the first term. We already got the second term. I'm just going to steal it. We got to make the third term. What's 2 cubed? 8, so 1/8. Now, you could type this all in your calculator and add it, but let's work smarter, not harder. I already know the sum of these first 2 terms. We did it over there. So really, in my head, I would do 3/4 plus 1/8, making common denominators. This is 6/8. What's 6/8 plus an 8? 7/8. Not that you can't just straight type those fractions in, but let's work smart here, right? Okay, 4 terms. We got the first already, we got that second, we got the third was an 8. What's the fourth term? 1/16. Now again, you could straight add those 4 fractions in your calculator, but let's work smart. We know the sum of the first 3 terms. I'm going to steal it from up here. The first 3 was 7/8. And I got to add the fourth. Well, I can turn this into 16ths mentally and add it. How many 16ths do you end up with? And again, I don't care if you just add the 4 fractions, add the 3 fractions, whatever, but try to work smart and use some of the other previous sums to help your cause, okay? So that is no different, like if for this guy, if I gave it to you like this. What's the variable, n? That's an n. This is the same thing, it's just a different notation, okay? All right, for the series, find the third partial sum and the sum. Okay, third partial sum. So I need, just like I was doing, the sum of the first 3 terms. Well, let's put 1 in, of course, 10 to the first 10. Then I'm going to put a 2 in. What's 10 squared? 100. What is 10 cubed? Now, we need to add these. You could either, get a common denominator, do all that work, or to help us with the next part, let's think of these in decimals. 3/10, 3/100, 3/1000. So what do you get when you add those 3 decimals together? Okay. Now, B. Find the sum. Oh boy, okay. So they want all the way out to infinity. Am I going to write the terms up? No. I'm going to use this to help me. I got the first term. I got the second. We did the third. I can make the fourth, all about patterns. I can make the fifth. I could keep going. How is this answer going to be similar but different? So it's 0.333 repeating. Or you could write this 0.3. We can go 6th grade math with a, remember that? Or what's 0.3 repeating as a fraction?
1/3.
I like the 1/3, but you can list it however you want. So you will see a pattern to get to the infinite sum using the first few terms, okay? Now, do you have to write out a million terms over there? No, you can probably figure it out if you do A, okay? Questions on that? All right, let's review for the final. Are we ready? I love the enthusiasm class. I love it. Okay. Now, first off, don't forget, you will be given or provided the identities from Chapter 5. Cos of a double angle, just for reference, is on the back side at the bottom. There's 3 formulas for it. I'm just going to jot one down here. Okay. Now, before I can figure out, we know what cos is, clearly. I need the sine. So I'm thinking about, A, where am I going to draw? I'm going to make the triangle, blah, blah, blah. So this, of course, is going to tell you where to draw it. You're in radians. We can handle radians. What quadrant is that telling you? 2. You're between 90 and 180. 2. And cosine, of course, adjacent hypotenuse. Now, is this a Pythagorean triple? No. You're welcome. So we're going to have to use some old school Pythagorean theorem. I mean, that's not that hard. Okay. So I'm going to do a squared plus negative 2 squared. Why am I putting 49 squared? How about 7 squared, which is 49? Okay, subtract your 4 over, you're going to have 45. We're going to root it. We're going to simplify it. What's the square root of 45 simplify down to? Perfect. Okay, just check. Does the 3 square roots of 5 need a negative due to the location? Perfect. We got everything we need. Okay? Cos they gave me. I'm not even going to rethink it. And we're going to look over at that triangle and tell me what's the fraction for sine.
Oh,
3 square roots of 5 over. And now we're just going to do the calculations. 2 negatives make a positive. 2 squared is 4. 7 squared. I'm going to square everything here. 3 squared. Square root and square and cancel. 7 squared. We don't need a calculator. Final answer. Perfect. This is a throwback to chapter 5, which is the first chapter on the final exam. It's all coming back to you, right? It's all coming